Okay, so now we're doing the sine ratio. Again, this still applies to only right triangles. So we're going to learn some tricks here. When I was in school, my math teacher always asked me, or asked us, what was the first thing you do when you go into a pool? And he would always say, you would soak your toe. And this sounds like sew the toe up. So when I ask you, what's the first thing you do when you go into a pool? You would soak your toe. So obviously represents sine, and ka we'll see later. So I'll introduce the other two later. But right now we're going to do sine. It's not pronounced sin, it's pronounced sine. Make sure your calculator is in degree mode. It has a little DEG in the corner somewhere. You have to hit mode somewhere to adjust it. Okay, so you must always label your triangle. Always. Adjacent, hypotenuse, and opposite. So adjacent means beside an angle, or the dots, I would say. The hypotenuse is obviously your long side. And opposite, beside angle, sorry, I should say. And opposite the angle. So let's do some here. So the dot is representing the angle. Okay, this is the angle. And I would suggest putting your dot near the angle. So 30 degrees, 76 degrees, put the dot there. Now you should label it. Hypotenuse, that's a given. And your adjacent should go on the left-hand side because it's right beside the dot. That's what adjacent means. Adjacent. And opposite the angle will be the left over side. Opposite. Okay, so let's do the next one. Again, your dot is the angle on the bottom corner on the left. And so let's just write down angle. You don't have to do that every single time. But as long as you know where the dot should go, or where the angle is. Hypotenuse, again, is given. And this is adjacent, because it's right beside the dot. And this is your opposite. So those two sides are the, I think, trickier ones to remember how to label. Okay, so we've got labeling down. The sine ratio. So this is the sine ratio. Write down sine theta, which represents angle, equal to opposite over hypotenuse. And just that we know that this fancy little symbol with the O, this is the angle, okay? It's a Greek symbol for angle. You'll see other ones called theta and alpha, but right now we'll see theta. Okay, so opposite over hypotenuse. That's where we get the O over the H from so, katoa. Use your calculator to find the value of each of the trigonometric ratios to 4 decimal places. So what you do is just type in sine 21 directly into your calculator. Sine 21, enter. And again, make sure your calculator is in degrees. Let's do this to 4 decimal places. And this will equal to 0.3584. Cos 73. Now let's try cos. That's the second one. That will equal 0.2924. I just want to show you the differences. Sine 30, again, to 4 decimal places is 0.5000. Determine the length of PQ to 1 decimal place. That's the first thing you should always do, is label your triangle. So, my dot is on the bottom left. So let's put a little dot just so we know. Hypotenuse is 10.4. I'm going to write down HYP for short. And my adjacent, ADJ, is beside the dot. And opposite is on the side. They want to know what PQ is. So let's put a question mark beside PQ. And let's call that X, okay? So let's set up our ratio. We have sine theta equal to opposite over hypotenuse. I think So far, so good. Now let's sub in what we know. We know we have an angle, and we know we have our hypotenuse. We don't know what opposite is. So let's sub in sine 67 degrees equal to opposite. We don't know, let's call it x. That's what we're representing it as. Hypotenuse, which is 10.4. Now, what the invisible number underneath sine 67 is always a invisible 1. Okay? We want to get x by itself, so what we do is cross multiply. And then again, we just had a proportion. 1 times x is x, obviously, equal to sine 67 times 10.4. So when you type in your calculator, it's very tricky that you put brackets under sine 67. What I would suggest is put the number that doesn't have the angle first into your calculator. So I would go 10.4 times sine 67 first. If you type in sine 67 times 10.4 and you forget a bracket, that will change your answer completely. So this is what I suggest doing. X equal to 9.6 centimeters. Okay, I hope that was clear enough. Now let's do some more stuff. So you'll see angle of elevation and depression. So when you go in an elevator, you're obviously going up. So you're elevating. So that's your angle of elevation. Elevation. Going down is depression. Kind of an easy concept to understand. So, a ladder, 8.5 meters long, makes an angle of 72 degrees with the ground. How far up the side of a building will it reach? So let's draw a little picture here. Let's draw a building. That's my door. And we'll draw the ground here. We have a ladder here. And it's on the side there. I'm not a very good drawer. Now let's label our lengths and measurements. So a ladder 8.5 meters long. So let's write down 8.5 because that's how big our ladder is. Angle with the ground, so that's our bottom here, 72 degrees. We want to know how far up the side of the building will it reach. So we're looking for the left-hand side because that's obviously the height of the building. So we don't know what that is. So let's put an X there. We don't know what it is. So what you should always do, again, I'm going to reiterate this over and over, to label a triangle. This is your hypotenuse, which should be the first thing you should always label. I'm going to write down H by P instead, actually. And my dot is right here, 72. I'm going to go adjacent because that is beside the dot. And X is my opposite. I kind of hope at this point you understand what I mean by labeling a triangle. So we're going to use sine theta equal to opposite over hypotenuse. Now, we're going to sub in our values. Sine theta, theta is 72 degrees, equal to opposite, which is x, over hypotenuse, which is going to be 8.5. So instead of just like we did before, I'm going to ask again, what is underneath sine 72? And you would obviously say 1. Pass multiply because you want to get x by itself. 1 times x is x. And again, you should always put your number first before your angle. So let's do 8.5 times sine 72. So then your calculator, and you should get 8.1 meters. So it's 8.1 meters off above the ground. Alright, next one. Brad is building a ramp. The ramp must form an angle of 22 degrees with the level ground and reach a point that is 1.5 meters above the ground. How long will the ramp be? So let's draw a ramp. Not very straight, but that's okay. So let's label our measurements. 22 degrees goes to the ground. And it must reach a point that is 1.5 meters above the ground. So that's going to be our height. We want to know how long the ramp is. So let's put a question mark and an X to represent that. Let's label a triangle. This is my hypotenuse. My dot goes there. That means my adjacent's on the bottom. My opposite's on the left-hand side. Okay, now we're going to set it up again. It's going to be a little bit different this time. Sine theta equals opposite over hypotenuse. This is good practice to write this out, so then you kind of stick it into your head. So let's sub in our values. Sine 22 degrees equal to opposite, which is 1.5, over hypotenuse. We don't know which is going to be x. Alright, again, underneath sine 22, hopefully all you say will be 1. And let's cross multiply. Alright, so I always do the letter first. So let's do x times sine 22 and put that on the left hand side, because some kids are very anal about putting their variables on the left hand side, which is fine by me. I'll do the same. So we go x times, and I put a little dot for representing the multiplying, and we go sine 22 equal to 1.5 times 1 is going to be 1.5. I want to get x by itself, but it's on sine 22 is on the other side, so let's get rid of it. The opposite of multiplying by sine 22 is going to be dividing. So I do to one side, I must do to the other. Sine 22 divided by sine 22 is 1, so that cancels out and leaves you with x equals 2. 1.5 divided by sine 22. So just type in 1.5 divided by sine 22, and you should get 4. 4.0 meters. You don't have to write the 0, but that's okay. One more example. The angle of elevation of Sandra's kite string is 70 degrees. If she has let out 55 feet of string and is holding the string 6 feet above the ground, how high is the kite? So let's draw a little picture of Sandra. Let's draw our little kite over here. And the string waving in the wind. This is Sandra's arm. And the ground below. So, she has let out 55 feet of string. And is holding the string 6 feet above the ground. So, let's say that she's actually 6 feet. Oh. Let's maybe drop it here, sorry. And her arms are like that. Face is like that. Yes. So let's say that this is 6 feet above the ground. So we have to account for that later. This is 70 degrees, and now we have to figure out how high is the kite. So let's put x beside the right hand side. Let's label a triangle. This is my hypotenuse, easily. Dot goes there, adjacent on the bottom, and opposite is what I'm trying to look for. Let's set it up. Sine theta equal to opposite over hypotenuse. I know my angle is 70 degrees, so I'm going to go sine 70 degrees equal to opposite, which is x, over 55. Oh, I cannot write 5. Alright, now we're going to cross multiply again. Underneath sine 70 is invisible 1. Good practice to write that in. Cross multiply. 1 times x is x. And we type in 55 times sine 70 in our calculator. That will give us our height of 51.7. Now that's only the opposite, but we have to count for that 6 feet. So what we do is just add it in. So our final answer is, plus our 6 feet, height equal to 57.7 feet. I hope that makes